Assalamualaikum warahmatullahi wabarakatuh. Hello everybody. Firstly, let me introduce myself. My name is Sofi Isda Wardani. I am from Chemical Engineering regular class in Polytechnic LPP of Yogyakarta. In here, I will explain about the optimization of baggase for boiler fuel in sugar factory. Previously, I will explain about what is baggase. Baggase is a residue from the milling process of sugarcane after it is extraction of or removed from the sugar refining industry, so that a large amount of fibrous waste byproduct can be obtained. In the sugarcane milling process, there are 5 times the process of grinding sugarcane stalk to produce baggase. Due to the fact that the world availability of fossil energy is increasingly scarce and expensive, this will have an impact especially for sugar factories that are still short of waste and there is no remaining oil to be burned as boiled fuel. Baggase is a renewable energy source and is available in large quantities which can be used as boiler fuel. Therefore, it is necessary to optimize the baggase used for boiler fuel, which is carried out through a balanced installation, effective equipment, as well as adequate quantity and quality of milled sugarcane. The energy requirement for the production of crystal sugar can be met by part of the residues from the final mill, and the excess waste can be sold as raw material for the papermaking, mushroom, and compost industry or sold as electricity. The use of energy in sugar factories can be carried out efficiently because it is carried out through a dual power generation system, or commonly called a cogeneration system. The system produced by the first baggase combustion boiler is used to drive the turbine generator or propulsion mill. The turbine also produces waste steam for heating the juice, evaporating the juice in the evaporator, and vacuum pump during crystallization process. With the use of a gas discharge system in the evaporator and the use of sugar vapor for the heating and crystallization process, sugar mill can obtain excess baggase up to 29%. The supply of fuel, including the efficiency use of electricity in some sugar factories, can cause the cost of producing sugar to increase by 10% or more. Therefore, a balanced installation is needed in an effort to optimize baggase. Then, in addition to balanced installation, efficient equipment is also needed. Therefore, the quality of the baggase of boiler performance also depends on the boiler design, the condition of the supporting equipment, as well as the control and operation equipment. In accordance with the existing boiler type, if the steam efficiency and production volume per kilogram of waste burned are very high, the boiler performance can be said to be optimal. The operation of a boiler that is below standard will cause the steam supply to the plant to be disturbed. Boiler loads are unstable and the production process is also disrupted. In boiler performance, tests carried out in several sugar factories due to poor boiler operating conditions, efficiency, and decreased steam production per kilogram of waste burned. The demand for boiler filling water can be met by pure condensate water from used steam at a temperature of about 95 Celsius from the evaporation station. Then, to optimize the baggase as boiler fuel, an adequate quantity and quality of milk sugar cane is also needed. The amount of pulp is influenced by the level of coir associated with the variety. Because the high and low level of coir are genetically inherited from the variety. High rendement sugarcane tends to have low coir content. Besides, the coir content is also influenced by the age of sugarcane. Young sugarcane usually has a low coir content, and while the ripe sugarcane has higher sugarcane content. At the beginning of the mill, most of the sugarcane content was still low, around 11%, so that sugar factories often lack pulp. As for the quality of the baggase is influenced by the moisture content of the baggase. By increasing the monitoring of milling, it is unexpected that the moisture content of the baggase of the driving material of all loaded system equipment can reach up to 60%, so that the change of final milling for the sugar factory are less than 50%, and the sugar content or pulp is 2.5%. To optimize the quality of baggase, it can be done by reducing the moisture content of baggase through the application of drying technology. So the conclusion that I get from the explanation that I submit is that the shortage of baggase in the sugar factory should not occur, and this can be overcome through optimization of baggase, production and consumption of steam, installation and smooth operation of mill. Sugarcane has quite a large amount of baggase, some of which can be used to meet the total fuel demand in the boiler. With a balanced installation, efficiency, equipment, and adequate quantity and quality of milled sugarcane, the sugarcane factory can obtain excess baggase or useful energy as industrial raw material. Okay, thank you very much for your attention. So my presentation, I hope it useful for you and you can really enjoy it. Wassalamualaikum warahmatullahi wabarakatuh.